Welcome. Today's lesson is on soil texture. Before we get into actual soil texture, I think it's probably best if we could define really what soil is. Well, a soil is kind of a unique substance or matrix primarily because it's made up of geological things or inorganic kinds of things, whereas you look at the biological or living things within it, makes it more organic. So it's kind of a combination of organic, inorganic, geological, and biological. So all of those cover a very, very thin portion of our planet. So it's extremely important. There's a certain group of people that still want to call it something else. And this guy here, he's pretty much kind of has definitive definition for what soil is. One does not simply call soil dirt. No, you don't. Soil is dynamic, natural body composed of mineral and organic solids, gases, and liquids, and living organisms which can serve as a medium for plant growth. The dirt under your fingernails cannot. At least he's in my corner. All right, so let's talk a little bit about soil texture. Soil texture is primarily determined by its size and type of particles that are in the soil matrix. And there are also organic materials as well. We'll be talking a little bit more about the components of soil, and we'll get to that a little bit later. But I want you to just concentrate on this whole idea of the size. The size in soil texture matters because it gives it a certain, texture, a certain feel. Because soil and soil texture is pretty much based not only the size but also the feel of it as well. So to kind of give you an idea of what's going on here, let's go ahead and look at this. And we're going to look at sand first, the sand particles. And the sand particle is 0.05 to 0.10 millimeters. It's very fine. You can probably, it's not microscopic, you can still see the particles. Now the largest kind of gravel size would be very coarse, 1 to 2 millimeters. And obviously you can see those. And so you can see that even though it's a sand particle, it varies in its size. Now understand there are 3 different types of soil textures. We have sand, we have silt, and we have clay. Those 3. And they all have different sizes, and even not only sizes, but also how they're shaped as well. And we'll get to that in just a second. And then we'll go to the next one. When we look at the comparison of sand and silt, you'll notice that sand is much larger than silt. Silt isn't quite microscopic, but it's very, very close. That brings us to, now, before I move on to the last one, remember, sand, when you put it between your fingers and kind of rub it back and forth, it's going to feel really gritty and hard and maybe even sharp to the touch. Whereas silt, because it's so small, it can fit into some of the cracks and crevices in our fingers, and in particular our fingerprints. And when it's dry, it feels kind of like a talcum powder, smooth. And if you've ever been like down at the river bottom, that's a lot of silt. You get it on your hands and even on your car, it really sticks. But also on your hands, it makes them kind of like not rough at all. It's really smooth. Now, and then of course, when we get to clay, clay is the smallest particle, and it is microscopic. And it has a kind of a different shape than everybody else. It's kind of plate-like. So when it's dry, it feels kind of rough. But when you get it wet, then it become very, very sticky because they like to stick together. Those plates are stacked on top of each other, so it's really hard to kind of separate them that way. So that's kind of how the 3 are designated, is obviously by their size. And then this last picture I want to show you, there's something else about these 3 textures that are also very, very important. If you take a look at this first one here, this is sand. And if you notice in sand, there are these little bitty particles. These are kind of the reservoir for water and also for the air. So if water is going to pass through the sand, it's going to have a pretty easy time going through it because the spaces are relatively large compared to the other ones, as you'll see in just a second. So it drains very fast. I used to work in Modesto, and they had some sandy loams. And after a heavy, heavy rain, you could get back into the field in 2, possibly 3 days because the water had passed all the way through it. So let's take a look at our silt. As you can see, silt and sand, they're quite a bit different. You can see the air pores there, and you can't really see them there. But on this drawing, you can see there's the pores themselves are quite a bit smaller, but still you can see that where the water can actually accumulate in, and it also will percolate through, but it's not going to be as fast, primarily because there's many more of those pores, and that's an important concept to remember, and I'll get to that a little bit later. But it's a lot shorter, so it takes a little bit longer for all the water to go through, and then of course at that particular point in time, it's just going to take longer for water to percolate through it, especially if you're talking anything between 0.002 millimeters to 0.05 millimeters. It'll probably get through, but not in a very dramatic fashion like sand would. And then let's go to clay. Clay is pretty compact. And because it's plate-like, so when tractors and things go on top of the soil, they get smushed down. And when they get smushed down a little bit, so does the air pores and the water pores. And because of some electric connections, water even sticks even harder to clay. So it's hard for it to move through. That's why every time you walk into a field of it, you gain about another 2 or 3 inches and about 8 to 10 pounds as you're walking through it. Because the water and the clay itself likes to stick together. They don't like to let go of nutrients or water. So let's just review very quickly what we have done at this particular point in time. If soil is permeable, that means that water can move through it relatively quickly. Sand is a great mover, and silt is kind of in between, and clay, it's hard for it to get through. So soils basically have these little tiny pores, and they tend to hold water, some better than others. Now, when we're talking about soil itself, understand that it's not just about a clay or a silt or sand. It's a mixture of all three of those. So, for instance, when you were to collect any kind of soil samples out in our garden or out by the greenhouse, you'll notice that they're not always behaving the same because there's different mixtures of soil particles or soil texture within it. And in order to be able to classify it, scientists need some kind of way, some kind of gimmick to be able to figure out, is this a silty clay loam, or is this a clay loam, or what kind of classification is it? And this is called the soil textural triangle. You'll be using them in a few days, but for right now I just want to introduce this concept. So this triangle, and notice if you will here, this is clay, so if your sample has anywhere between above 0 to 100, obviously it has a certain percentage of clay. So like for instance, a Myers clay is probably going to have anywhere from 20 to 40% take and then maybe a silt of 10 or 30. But basically what they do is they take it to a lab, and they can determine the percentages of each of these, and then you just draw lines through them, and wherever that line ends up, that would be the soil classifications. Like for instance, a clay loam that we have on our campus. It's called silty. No, it's a clay silt loam, I think it is. But anyway, you're going to be learning a little bit about that a little bit later. So I hope that's helped you understand what soil is, number one, but also what soil texture. So I'll see you in the lab. Bye.